Good evening, everyone. We have Mr. Carl Eberts from Hunter Industries to give a presentation and overview on Hunter products. Apart from whatever the Hunter promotional video said, there are a few other facts which we all must know about Hunter Industries. The founder, Mr. Ed Hunter, is reputed to have the highest number of patents in the world for irrigation products. Hunter Industries also sells the maximum number of rotors through its partners, and it included in the world. So Hunter Industries has been known for its innovation. It has got a huge sales of rotors, including the landscape rotors. It also has a legacy of having the highest number of patents among the irrigation products, primarily in the rotors. So I leave the floor to Mr. Carl Eberts and tell you more about Hunter Industries. Carl, all yours.
Thank you very much. Can you see my screen?
Yes.
Well, hello and good evening to most of you. My name is Carl Eberts, and I'm the Product Marketing Manager for golf products at Hunter Industries. So as mentioned, I'll be giving an overview of our golf rotors with a focus on the features of our latest and greatest TTS 800 series rotors. So that video is a good intro of the history, and we'll review our latest product. And then I'll also cover some of the common routine maintenance best practices for rotors and how our rotors are designed to make this as quick and painless as possible. The modern golf rotor really exists as part of a complete golf irrigation system, though. So I'll start with just some brief context of our system offering. So we have the Pilot Command Center software, fully redesigned, intuitive, easy-to-use interface. It's built on an agile software platform, so it's constantly being updated and developed with direct user feedback. This talks out to the controllers in the field. The integrated hub system is our decoder platform. And then obviously rotors in the field is where the action's at. So the Pilot network is our control system. You have the central computer talking to a field interface, and that sends out the commands to the controllers in the field. And so we have two main categories here that tie into the rotors. The field controller system, which is a conventional system. You have wires running out to each solenoid in the rotors in the field. And so these we call our E or electric rotors. And then the integrated hub system, as mentioned, this is for decoders, or what we call two-way modules. And this is denoted by the D in our rotors. Just a graphic here of explaining the differences. Two-way module system, you can see a single controller there with wires going out to the rotors and then daisy chained one to the next. So this saves significantly on wire cost, especially now where just raw copper is going up in price. You can get away with one hub or controller there, up to 999 rotors or stations on that single hub. But if you have wiring already in the ground going out to each rotor, this would be a conventional system where you're going to have more controllers and more wire, but there's advantages to this as well. So each one of these controllers can do up to 80 stations or control 80 rotors. Both of these systems are capable of both wireless and hardwire communication. So shown on the right, you have radio modules talking from the central office out to the controllers. But it could be a hybrid system, and you also have some situations where it's wired as well, and that can be wired from controller to controller. So getting into the rotors specifically, we have a good, better, best offering. So the entry level is the B series, stands for a block rotor. So this is a system where you have a handful of rotors controlled by a single valve. Often you'll see these looped on greens. The better is our G800. You saw this in the video. This is good for conventional systems. The flange compartment's not as big for housing all the decoder components. And that's really where the birth of this TTS 800 series came from, our best and top of the line rotor now. And that's what we'll focus more on the features of that as we get into this. So as mentioned in that video, the G800, this was the first total top serviceable rotor released back in 2001. There's been a lot of development on it since, improvements, incremental. This really started the total top serviceable movement and has been a really successful rotor. But with the advancements of and adoption of the decoder systems, including that, we launched this TTS 800 series rotor in January of 2020, and it's really taken off now. As you can see, the flange is significantly bigger. The internals are the same, so this drive system has been around since 2013, so is very much field proven. But the body is fully redesigned from the ground up for modern irrigation systems, and we'll get into more details on that. So here you can see the 4 different internal riser assemblies that are offered across the board. The 835 on the left there is a shorter radius and lower flow option, typically used on tee boxes. It's for those shorter distances, sometimes on surrounds as well. The G880 is our full circle dedicated model. So it comes factory as a full circle and it's not adjustable. And this is denoted by the black collar there you can see. The 84 is adjustable, but comes set as a factory full circle model. So the nozzles are rear facing, but it can be adjusted to a part circle arc setting. And then the 885, our most common model, this is the part circle. It's adjustable there, both of those denoted by the gray color for their adjustability. This is what often is installed around greens and then on perimeters as well. So total top serviceability, this is the driver of this new model. You can see here in this clear demo, you have the yellow decoder in there. Everything's nicely tucked off to the left, and the whole right side of this flange compartment is available for wire connections. So you can actually fit 2 full-size DBYR6 connectors and even have room to spare for future technology. The inlet was redesigned on this. Heavy-duty PVC inlet is welded into the bottom for extra durability. You can see 3 ports of entry there. So those 3 holes are designed for allowing wire to come in from one side, splice in the compartment, and then you can daisy chain out to other rotors in the field. And so this is really convenient for those 2-wire systems. And then the single point of entry in the largest flange compartment, in the center there is a single quarter turn screw. So with just one quick turn of the screw, you can release the lid, pop it out. That screw is also captive, so it makes servicing in the field really easy. And then you'll notice the blue engraved distance marker on the lid, a yardage marker. This comes standard in black factory, but is available in a variety of colors to denote different yardages. The video mentioned this briefly, but this is a really cool piece of technology, the ICDHP, or the handheld programmer. This allows the 2-way modules to be wirelessly programmed through the lid. You can also perform diagnostics simply by placing the induction cup there in the middle on the top of the rotor shown. So this saves a ton of time in the upfront installation. Instead of having to write down serial numbers on every one of the decoders or control modules, and then manually input those into a controller or into your computer. you can just wirelessly program these in the field, not removing the lid or anything, just set the cup on top, assign the station number. And just the details were really thought out through this whole design process. So all the serviceable components inside the flange are color coded to make life easier. If you have a service tech out in the field and they're talking on the radio asking, you know, what component to look at, you could say the teal knob there is the pressure regulator. Or if you need to service the solenoid, you can remove the blue bracket and pull out the solenoid. And this view just gives you a good idea of just how much volume is in there. You can see the full DBYR6 wire connectors there on the side and all the space in the flange compartment. Taking a look at the internal drive assembly and an exploded view there. The gear drives, this is the same gear drive on the B series, G800 series, and this TTS 800 series, released back in 2013, redesigned from the ground up with a planetary gearbox that is patented and highest torque in the industry to power through any debris and dirty water in your system. On the top there is our exclusive pressure port nozzle technology. And so this optimizes the pressure at each nozzle and is a major reason for our rotors performing so well in distribution uniformity audits. You can see each one of those side nozzles has a chamber going directly to it, and then that's isolated from the main nozzle. So you get optimized pressure at each one of those outputs. There's an adjustable high torque stator assembly, so you can adjust the speed of rotation. And then the simple arc adjustment we'll show you here. So this tool, or you can just do it by hand, turning that adjustment collar makes it very easy to adjust and set the arc in the field exactly how you want to. This is another great feature of these rotors, the serviceable inlet valve. So all those components shown in green there are serviceable. So if the inlet valve got clogged or damaged, you can service those components rather than having to pull out the whole thing and replace the entire valve. So this saves money and time. The stainless steel filter is a mesh filter screen that protects the control components up in the flange. And then our proprietary filter Sentry design actually cleans off that filter with every activation. So it's designed really to clean itself and minimize the amount of time you even would have to service it with dirty water. I'll show you this animation here. So you can see as this valve opens and closes, that wiper is actually scraping across the fine mesh filter and taking off any debris or algae that would build up on that filter screen. So we found really, although it's designed to be easily serviceable, you're not having to service it as much in the field. But of course, if you have dirty water or growth in the mainline pipes, it's possible for the inlet valve to get clogged. So here's just a couple slides on how easy it is to service. Just a quick turn of the rock screen, and that can be taken off or replaced, cleaned out or replaced. Once that's off, even the little mesh filter screen can be pulled off and replaced or cleaned. And then finally, the seat seal that seals on the rock screen when it's closed. Removing these two screens, it can be pulled off and replaced as well. And so all those components are a lot less expensive to replace and service than an entire inlet valve. This is a great feature as well, the servicing of the regulator and solenoid without depressurizing your entire system. So the selector switch number 2 there, it can be turned to the on, off, or auto position. When it's in the off position, it actually isolates the flow from the valve, stopping it from going to either the solenoid or the regulator. So without having to shut off your isolation valve down the line, you can just turn the selector switch to the off position. You could take out the pressure regulator and adjust it. Or if you had to replace the solenoid after a surge event or something, it makes it a lot easier and saves a lot of time. And then we have shown number 4 there, actually another mesh filter screen, stainless steel filter screen. This just is another line of protection to control the control system components. So without a TTS system, you could easily be looking at an hour of work just for a basic routine maintenance. You're gonna have to shut down the water on the main line, make sure it's drained enough to bleed off the pressure, dig out around the rotor to access the serviceable components, take off, say, the solenoid if it was hit by lightning or surge, and then you're repairing the turf around it, and of course leaving unsightly scars on that, and then starting the system back up. With this total top serviceable technology, it's really 15 minutes or less, turning it off at the rotor. So as I mentioned, the selector switch turned to the off position, opening up the lid compartment, just the quarter turn screw, quickly replace any components, close it back up, and you're good to go. Another feature that's accessory really for these rotors, but is a unique application. These rubber cover kits. So we offer a low bounce and a no bounce turf cup kit. The low bounce one you can see on the left there comes in both green and black. And this has a pattern on the top that's designed to reduce the how far the ball would bounce if it hits the top of the rotor. So instead of a hard plastic surface, this rubber will dampen the ball and it won't ricochet as far. So these are often installed around the green. People are having approach shots. If you miss the green just slightly and it ricochets off the rotor, they're penalized obviously more than they should be. And then the turf cup on the right, not as common to see these installed on golf courses. They're quite popular on sports fields. But this would be buried down in the ground a few inches and is fully invisible from the top. So we'll switch gears slightly and talk about distribution uniformity, which is a major feature of all our rotors and is really key to maintaining a pristine course. We'll also talk a little bit about some of the maintenance practices you can implement to improve distribution uniformity. So good quality turf really is all about uniformity as far as the irrigation goes. On the left, you can see evidence of poor uniformity. This is actually the same hole 1 year prior and 1 year after, just after replacing rotors. So you can see all the dry spots. You don't have head-to-head coverage. You're not getting good uniformity even in certain areas at all. And then on the right, very uniform turf. Often the concepts of efficiency and uniformity are confused when it comes to irrigation. So I think this graphic helps explain it or just make it clear visually. Efficiency is affected by the operator and is really the ratio between the amount of water the plant beneficially uses compared to the amount of water the irrigation system applies. So on the top, you have efficient irrigation, giving it the depth of water that the root zone needs. below that would be not efficient, overwatering, so you're wasting water, potentially giving the plants too much water. In contrast, uniformity refers to how evenly the water is applied over a given area. And this is affected by the performance of the equipment itself. So on the top would be good uniformity. It's even across the playing field. Obviously, it's never going to be perfect. Perfect uniformity would be 1.0 or 100%, but above 85% is going to be excellent uniformity. On the bottom is clearly poor uniformity. You have more water, deeper water depth in certain areas, so you're applying too much water in some areas and not enough water in others. Or if you really, got those stressed areas, more water, now you're even applying extra water to other areas. So it's a waste of water and just doesn't produce good results. So how to improve distribution uniformity? Ensuring rotors are level is a basic one, but very important. Confirming rotor-to-rotor coverage. If this is not the case, there's a few things you can do to try and achieve this, looking at changing nozzles or increasing pressure. But if you go through all these maintenance practices and still do not achieve a good distribution uniformity, then it's probably time to start considering upgrading your irrigation system with the latest and greatest rotor technology. So this first thing may sound obvious, but with settling over time, rotors can become not level or flush with the surface. And it's really important that this is level with the surface to achieve optimal watering performance. Also over time, top dressing or settling the rotors could end up significantly lower than the surface. In this case, the rotors should be raised up to be flush with the surface. This is to prevent the shorter range nozzles from hitting the edge of the ground around it, which would negatively impact the performance. You're just not going to get enough water in the short range areas. The rotor should be throwing water all the way to the next closest rotor. This is often referred to head-to-head or rotor-to-rotor coverage. In the diagram here, you can see how a properly designed and performing system, all rotors are covering the distance up to the next closest rotor. So you have part circles on the side going 180 and making it up to the rotors across and next to it. And then you have 90-degree rotors in the corners also making it up. So this leads to the most uniform coverage throughout the area. If the spacing is designed correctly, but there are rotors that are not reaching the next head, it's possible that the pressure is too low. So the best way to confirm the pressure is using a pitot gauge to measure the pressure at the main nozzle. So you can see the pitot gauge shown there sticking into the water stream. It's important to note here, though, that there is a pressure loss through the body and the internals of the rotor. So the pressure at the nozzle is inherently going to be less than the pressure at the inlet of the rotor, and especially less than pressure downstream on the pipe. You're going to get more pressure loss through the pipe, clearly. So if you're still not achieving head-to-head coverage, but have good pressure, it's possible you need to switch out the nozzles to a larger nozzle to get further throw on the radius and get that head-to-head coverage. We offer a large range of nozzles to fit the needs of every application, and these can be easily switched out in the field. Also, it's rare, but it's possible for debris to damage the nozzles over time, which will negatively affect performance. If this is the case, the nozzles would need to be replaced. Now, if these general maintenance steps have not, or have all been done, and as I mentioned, you're still not getting good uniformity, then it's time to consider replacing your rotors with the latest technology. So that was the situation for Moorpark Country Club. The flyover of a distribution uniformity audit that was done there did the distribution uniformity audit on the rotors that were in the ground, and then dug those up, and then in the same conditions did the Hunter rotors right after. And so run through just a quick case study of the results of that challenge. So the rotors in the ground were calculated out to a 69% distribution uniformity, or a runtime multiplier of 1.23. So you're going to have to run the rotors a lot more to get water to those lower areas. The Hunter rotors showed a distribution uniformity of 91%, so a runtime multiplier of only 1.06. So much more efficient in the application of water there. So this shows the calculation of how much water you would save, assuming 260 cycles per year, so 5 days of watering a week, which is typical, especially out here on the west coast of the States. So you'd have to run 19.2 minutes of what was in the ground versus 17 minutes for the Hunter 85s around the green. So this almost 3 minutes difference of head at a 23 gallon per minute nozzle, or 87 liters per minute, works out to 58 gallons, or almost 220 liters per head. You multiply that out by, in this case, if they had it across their entire course, it'd be 1,800 rotors, but you could insert, whatever total number of heads, replacing all of them. That's over 100,000 gallons, or almost 400,000 liters per cycle. So times that 260 cycles per year, you're talking about over 100 million liters of savings in water per year. So significant amount of water savings from an environmental standpoint, as well as just a cost standpoint. So calculation based on their water cost, it was almost 65,000 US dollars annually that they would save on water costs alone. And this doesn't even include the pump cost savings. So obviously electricity and wear and tear on your pump station to pump all that extra additional water out to the field adds up quickly. Of course, there's not only the water savings and uniformity and application and the look, but the playability of the turf and how uniform that playing surface is, especially on the greens. So this was a month-long study we did with the Pogo moisture sensor that you can see there. So the handheld probe is a dielectric impedance sensor, measures soil moisture, salinity, among other things. In this case, we were just looking at soil moisture. So the superintendent or greenkeeper did measurements across the green over a month period and found that the Hunter rotors outperformed a leading competitor by 13% on that moisture uniformity. So we'll end with a quick project highlight. Ostrucker's Golf Club. This is actually up in Sweden, but is a cool project to highlight because it was done with the Henrik Stenson golf design firm. This was his first golf course that his firm designed. So for those of you that are into golf, which I assume everyone here is, you would probably recognize the Henrik Stenson's name. He won the 2016 Open Championship, beating out Phil Mickelson just barely. This was established in 1988, but they came to us to do a complete renovation. It's a 45-hole course, so 2 18s and a small short course. I'll show you a picture of that here. So it was a phased renovation, so they did an entire 18 first, and then the par 3 short course, the 9-hole in the middle, and then the remaining 18. And so there was a lot of logistics and planning that went into this. Teamwork was critical, and we worked closely with them to deliver product as needed, and worked and sent people on site to help manage the installation and growing process. So here's a picture of the grow-in on the left. You can see the seeds starting to take. On the right, the hole is just being shaped and prepared. So rotors installed, but even at this point, it's very critical, especially to have uniformity of that grow-in period. Looking back at the controllers as well, mentioned at the beginning, the flexibility to run the rotors via standalone controllers before the central computer was even installed was key to the success on this project. So without the central computer and all the communication back to the maintenance shop being installed, they could just install controllers hole by hole, connect those to the rotors, and then run those manually as they're doing the grow-in process. And here's the final product. So you can see it turned out to just be a beautiful course there, water features, and then the turf is in perfect condition there, overlooking the clubhouse in the background. With that, we just mentioned we take pride in providing golf professionals with the tools and support they need to conceptualize, create, and manage world-class golf courses. Thank you for your time, and check out our website there, hunterindustries.com/golf, to learn more.
Carl, thank you very much for a very detailed presentation. There's a question from the audience.
Sure.
What is the importance of weather stations? I mean, sometimes in some courses have a very, very elaborate weather stations. Do you need that kind of data, or is it something which is superficial?
No, it is valuable. It depends certainly on your climate. Some courses will actually have multiple weather stations if it's really spread out and they find they have a microclimate on one end of the course versus the other. And so our central control software can take that data, even ET data, and then you can use that to adjust your irrigation from a day-to-day standpoint. So it's not necessary, but it certainly is valuable as an additional tool.
But would you think that a simpler system which gives you relative humidity, wind direction, temperature would suffice in most of the cases in a country like India?
I would think so. I mean, you get microclimates around mountains and stuff where certain holes are tucked in completely different areas. So I think, as far as I know about the weather in India, it would be consistent enough across your course with that info. You would be okay.
Thank you, Carl. Thank you for a great presentation.